Good morning, one and all. Welcome to JCE Connect. This is Professor Vinayak Nannoji from Jain College of Engineering, Belgavi. So we are into module number 4, and we are learning joining processes. In that, we will be learning about soldering, brazing, and welding process. So first, we shall start with welding process. So what exactly we mean by welding? So the definition goes like this. Welding may be defined as a metallurgical joining of two metal pieces together to produce essentially a single piece of metal. So it means that joining of two metals together is called as welding process. So there are various definitions of welding process. So before that we shall see what is the principle. In that we shall also see the other definition of welding process. So welding is a process of joining similar metals by application of heat with or without application of pressure and addition of filler materials. So the result is a continuity of homogeneous material of the composition and characteristics of two parts which are being joined together. So the application of welding are so varied and extensive that it would be no exaggerations to say that there is no metal industry and no branch of engineering that does not make use of welding in one form or another. In fact, the future of any new metal may depend on how far it would be lending itself to fabrication by welding process. So here, as I said, welding is a process of joining two similar materials by application of heat. So here heat is very important. We have to generate heat so that the heat can be used to melt or to transform it to plastic state, and then we may or we may not apply pressure. So this comes under different welding processes. Whether we apply pressure or whether we do not apply pressure depends upon which type of welding we are doing. And also usage of filler materials. So in some of the cases we use filler materials, and in some cases we do not use filler materials. So filler materials are of again different types that we term them as electrodes. Okay, and then we have bare electrodes, then we have coated electrodes. We shall see those things in a later stage. So the next is the classification of welding. So what are the different types of weldings which we are going to study? So here you can see in figure number 4.11 we have different welding processes. In that first one is the gas welding. So in gas welding we have three types. One is oxyacetylene welding, in which we use oxygen and acetylene to generate heat. And then in second we have air acetylene, wherein we use air and acetylene gas. And then in the third case we use oxyhydrogen, that is called as the oxygen and hydrogen together is used to generate heat so that we can melt or we can bring that two pieces or two metal pieces into plastic state. Then the next one is called as the resistance welding. So in resistance welding we use current, and then we use the, or we can say that resistance of the material is used, and in that we have three types. First one is called the butt welding, second one is called as the spot welding, and the third one is the seam welding. And then comes the third one, that is called as the arc welding, which is the most common of all, and in almost all industries and everywhere in engineering we use arc welding as one of the most commonly used process, because it has certain advantages, and also because of the metal being formed after joining are very strong. So in that first one we have carbon arc welding, second one as metal arc welding, then we have plasma arc welding, and then we have gas metal arc, which is also called as MIG, that is called as metal inert gas welding. And then the last one is called as the gas tungsten arc, which is also called as TIG, that is TIG welding, that is nothing but tungsten inert gas welding. And then comes the newer welding methods. In that we have two types. The first one is called as the electron beam welding, and the second one as laser beam welding, wherein we use laser to generate heat. And then the last one is called as solid state welding. So in this we have different types. First one is called as the friction welding, second one is the ultrasonic welding, third one is the diffusion welding, and then the last one, the fourth one, is called as the explosive welding. So these different types of welding methods are used according to the application. It all depends upon which material you are going to join, and the material after joining, what is the application of that material, whether it is going to be under a compressive load, or whether it is going to be on a tensile load. Are we manufacturing a boiler, right? So if we are manufacturing a boiler, then it has to be very strong, so that time we cannot use normal arc welding method. We have to go for different welding methods. So this all classification depends upon which type of welding process is required and what is the application of the end product. So after joining, where exactly that component is being used, that is very important. So depending on that, we decide which process or which welding process has to be used. So next one is types of welding process. So in this we have two different types. So all these classification depend or are working on the principle of these two. The first one is called as the pressure welding. So in pressure welding, the parts to be joined are heated only up to the plastic state. Means what? It is not melted. It is only heated up till its plastic state, and then it is fused together by applying external pressure. So what exactly is done here is that if two pieces are to be welded, then we heat those two pieces at certain temperature, wherein we call it as a plastic state, right? Or you may also call it as a red hot condition. And when it reaches that red hot condition, then we apply external pressure. So that pressure depends upon again there are again many types of pressures, like we have forging pressure, we have resistance, right? So when the external pressure is being applied, then it gets fused with each other, and then it bonds, and then we get a one material, that is two materials are joined together. So here the pressure welding, the parts to be joined are heated only up till plastic state and then fused together by applying external pressure. So in this there are different types of pressure weldings are forge welding, and then we have resistance welding. Then comes the fusion welding. So in fusion welding, which is also known as the non-pressure welding, the joint of the two parts is heated to the molten state and allowed to solidify. Means what? If we want to join two metal pieces, so these two metal pieces are heated up till a temperature wherein it starts melting. So once it starts melting, then we allow it to solidify, then they'll fuse together by itself. So the different types of fusion welding are arc welding and gas welding. So arc welding is most commonly used. Arc and also gas welding is most commonly used in almost all the applications. And now we shall see what exactly is arc welding and how arc welding is done. So next one is the arc welding. So the principle is as follows. When two conductors of an electric circuit are touched together. So we have two conductors of an electric circuit, okay, say positive and negative. These are touched together momentarily. So when you take two wires and then you touch those two wires when they are connected, then you will see there is a spark, right? So then instantaneously you will get a spark, and then you separate it, assuming that there is sufficient voltage in the circuit to maintain the flow of current. Then an electric arc is formed. So when you touch two electric wires together, then you will start getting spark, and then once you touch it and then you take it a bit far from the wire, but you will assure that still there is flow of current, then there is a formation of arc. So this arc is what we are using in this method to generate more amount of heat. So here after the arc is formed, the concentrated heat produced throughout the length of the arc will be at a temperature around about 5000 to 6000 degrees centigrade. So you can imagine the temperature of arc welding, it is almost up till 6000 degrees centigrade. And also you should remember the temperature range, because it is asked many times in the exam, what is the temperature of arc welding. So at that time you have to write that it is about 5000 to 6000 degrees centigrade. So in arc welding, usually the parts to be welded are wired as one pole of the circuit, and the electrode held by the operator forms the another pole. So here you can see, so this is the electrode, okay, this is formed as one pole, and this work is formed as another pole. So you can see here we have three diagrams, A, B and C. So in A you can see that there are two metal pieces. So before joining these two metal pieces, we chamfer it, we do filing to it, and then cleaning process is done. That is, we remove all the dust, and then any oil stains or grease or any dirt, if it is there, that then it has to be cleaned to get a perfect weld. So here you can see in figure number A, here the these two pieces are to be joined together. So whenever we are going for an arc welding, then edge preparation becomes very important. So without edge preparation, we cannot do the welding process correctly. So here these two metal pieces, before it will be like this. So these will be the two pieces which are supposed to be joined, and then you can see here that it is being chamfered from here like this, and then chamfered from here like this. So this is how we have chamfered it here, right? So that the weld material will get deposited here, right? And then we machine off this part, the upper part, and then we get a perfect weld like this here in figure number C. So here in figure number B, we can see the different parts which are there in an arc welding process. So these are the two materials which are supposed to be welded. This is called as the electrode. This is the flux coating. So we have a coating on the electrode. So we have different types of electrode. The one electrode is one in which it does not have any flux, then it is called as a bare coated, and then one more is called as the coated electrode. So here this is a coated electrode which contains flux. So flux is used so that it forms a gaseous shield, and it will not allow it to, or allow the molten metal to come in contact with the atmosphere, so that oxides are not formed, right? So here you can see it is an electrode. Then we have a core of electrode, which is nothing but a material which is similar to the material of the parent material. So these material which are supposed to be joined, this material and this material will be similar. So the electrode selection becomes very important, and you can select electrode depending upon which material you are going to weld, right? And then you can see here, this is the gaseous shield here, and then we have a slag formation, that when this gaseous shield or this flux will after the process is completed, when it cools down, it forms a slag, right? Here you can see this one, right? So this is called as the flame. This flame we have got it by striking the electrode and the workpiece. So workpiece is connected to one pole and electrode is connected to the another pole, as said earlier. So when we strike it, there is a arc formation, and then we maintain a proper arc length, right? So that the arc will be continuous and it will not stop. And then it is called as, and then we generate the heat, and this heat is about 5000 to 6000 degree centigrade, which can melt almost all commercial materials. So once the welding starts, both the materials to be welded starts melting, and then there will be a formation of crater, right? And then with the electrode, even the flux starts melting, and that forms a gaseous shield around the metal piece. So this gaseous shield will protect the molten metal coming in contact with the atmospheric air. So if it comes in contact with the atmospheric air, what happens? It will form oxides, and these oxides will weaken the welded material. Okay, so here is a molten pool which will not come in contact because of the gaseous shield, and the welding starts from this point, and then it continues like this here, and these two metal pieces are joined together. And here you can see the weld metal will be deposited here. So these lines you can see here, these are the welded part. So these two metals are joined together. So this will be clear in figure number C. So here you can see the gap, whatever was here. So whatever gap was there here, it has been completely filled with the metal. So this metal is nothing but the metal from the core. So this core metal gets deposited in the space what we have formed here, and then this will form a homogeneous metal. Means what? This material, material number 1, material number 2, and this junction will be homogeneous. Means what? All the composition will be similar and it will form a very strong weld. And the slag, whatever is there remaining, it will be chipped off. So we have something called as a chipping hammer. So with the chipping hammer we chip off the slag, and if we want we can also machine it. Then you will form a single component, and you will not even understand that these two metal pieces are joined together. So whatever was the slag here has been removed off. So this is called as arc welding method. Thank you.